Alright, let's solve the following system via the elimination method. So if we're using the elimination method, the way we're going to do this is we're going to move all the variables to one side of the equation, and we're going to leave the constants on the other side. Now this is going to help us to kind of navigate through the process, so I'm just going to show it to you guys. We know that this equation has a left side and a right side, right? The equal sign kind of separates the two sides. And what I want to do for each line is I'm going to make sure that the variables stay on one side, and I'm going to move the constant and make it on the other side. So for the first equation, for line 1, I'm going to keep the 2x minus y on the left side. I'm going to move the 4, I'm going to move the 4 to the other side. So this becomes negative 4 becomes positive 4, right? And I'm going to do the same thing for line 2. So line 2 here we have 3x plus y, so I'm going to leave this on the left side, and I'm going to move the negative 11 to the right side. And the reason we're doing this is because it helps us to solve a lot easier. And when we're solving these linear systems, we've basically, a solution to a linear system is a point of intersection, right? So it's basically where the two lines will meet, right? And we'll also explore cases where there is no point of intersection. In that case, there's going to be something wrong with the equation. We actually will create an inequality. So I'll take a look at that later on, but for the time being, this is what we have. This is our setup. And when you're looking at elimination method, you're actually adding and subtracting equations. So let's call this equation 1, let's call this equation 2, right? And the whole point of the elimination method is you want to eliminate one variable, eliminate a variable, and you want to isolate and solve for another. And isolate plus solve for the other. Okay, so you can pick and choose which variable you want to eliminate, and as a result, which variable you isolate. Now, a rule of thumb is you can only add and subtract equations collectively, right? You can also multiply the equations separately. So I'll show you guys that when we look at this. But the easiest way to eliminate a variable is to make sure that the two variables are the same, right? And either they have the same sign or opposite sign. So if we take a look at this system of equations, we have 2x minus y is equal to 4, 3x plus y is equal to 11. You can see that y is common between the two equations, right? However, in equation 1 we have negative y, in equation 2 we have positive y. If I wanted to eliminate y and subsequently solve for x, to get rid of y, what I could do is I can add equation 1 with equation 2. And when you add equations, you have to think about the equal sign as just dividing the left side from the right side. Okay? So when I add the equations, what I'm doing is I'm adding everything on the left side collectively, and I'm adding everything on the right side collectively. But I don't mix and match, okay? Now the reason I'm adding these equations is because if you add these two together, you get 2x minus y plus 3x plus y. You can see that the negative y and the positive y cancel out and become 0. And you've effectively eliminated y. Now if you add the right side, you have 4 plus 11, you get 15. And then you can combine the like terms, so you get 2x plus 3x, which is 5x, is equal to 15. If you want to solve for x, I'm going to divide this by 5 and this side by 5. So x becomes equal to 3. Okay? So that's how you can effectively solve for the other variable. Now if you want to solve for, in this case we have x is equal to 3, you want to solve for y, you can resubstitute this into one of the equations. So if I resubstitute this into equation 1, and I'm going to use this version of it, you get 2 times 3 for x minus y is equal to 4. 6 minus y is equal to 4. I'm going to move the y here and the 4 here. Y is equal to 6 minus 4, which is 2. Right? And you can basically solve for the point of intersection. So the solution is the point 3 and 2. That's the idea. Okay? Now, a really simple way that most people will do elimination is they'll just add the columns. Sorry about that, guys. You just add the columns in this case, right? So 2x plus 3x, that's 5x. Negative y plus y is 0. And 4 plus 11 is 15. You can see that I just bring down the equal sign. And then you can just solve for x. So this is a really quick way of solving linear systems. Alternatively, you can also use the substitution method. However, in certain scenarios, especially when you do have equations in standard form, elimination is a lot more advantageous. So this is really useful. It's a great tool to not only solve for linear systems, but also when we're looking at word problems and linear applications. Okay, so let's solve the following system by elimination. So when you're looking at solving equations by elimination, what you want to do is you want to keep the variables to one side and the constant to the other side. So if you set it up this way, it's going to make it a lot easier to work with. So let's call this guy equation 1, let's call this equation 2. So equation 1, I'm going to keep the variables on the left side, and I'm going to move the constants, keep them on the right side. So I'm going to keep the y plus the 2x on the left side, and then I'm going to move the 3 to the other side, the negative 3 to the other side, which becomes positive 3. Equation 2, we have, I'm going to move the 4 to the other side, so we have y minus 1/2 x is equal to negative 4. And now that we have this, what you want to do is you want to ask yourself, okay, what variable do I want to eliminate and what variable do I want to isolate? So let's say we want to eliminate, and the easiest way to do this is I would look at the variable that is the same between the two, and you can see that y is the same between the two. Let's eliminate y, solve for x. And you don't have to always eliminate y, but in this case, y is the same, right? So let's eliminate y, solve for x. If you want to eliminate y, you can see that this is positive y and positive y for both cases, right? So you can either add or subtract equations to combine them effectively. Now in this case, to get rid of the positive y's, I'm going to subtract the equation. So I'm going to subtract equation 2 from equation 1. So if I do that, if you guys look at it, this is the left side, this is the right side. When you're adding or subtracting equations, you can only combine the left sides together and the right sides together. So I'm going to combine the left side together and the right sides together. So if I combine the left sides together, we get y minus y, which is 0, 2x minus negative 1/2 x, right? And this is equal to the right side, 3 minus negative 4. Okay, and in this case, what you're going to get here is 2x plus 1/2 x is equal to 7. And if you want to simplify this, this is 2 over 1x. You can also write this as 4x over 2. It's the same thing as 2x. Plus 1/2 x is equal to 7, which is basically 5x over 2 is equal to 7. And if you want to solve for x, I'm going to multiply this by 2 to get rid of the 2 on the denominator, and I'm going to do the same thing to this side. So 5x is equal to 14. If you divide by 5 to both sides, x is equal to 14 over 5. Okay, so that 14 over 5 is the x value of the point of intersection. To find the y value, what I'm going to do here is I'm going to substitute this into one of the equations. So let's say I sub it into equation 1. We get y plus 2x is equal to 3. If I plug in for x, 2 times 14 over 5 is equal to 3. So you get y plus 28 over 5 is equal to 3. And I move this to the other side, so y is equal to 3 minus 28 over 5. And the 3 here you can multiply by 5 and this by 5. Y is equal to 15 minus 28 over 5, which is basically, this looks like negative 13 over 5. And that's your y value. So this is actually your point of intersection, which is your solution, right? So you get 14 over 5 and negative 13 over 5. So that's basically how you can look at it using substitution. So you have to be very careful. You don't always have to add the equation. You can also sometimes subtract the equations. It depends on which variable you're eliminating and what you're solving for. Okay, so let's take a look at another question. We're going to solve this linear system by using the elimination method. So here we have two equations. Y is equal to negative 1/2 x plus 2, and y is equal to 3x minus 5. And what we want to do here is, if we're solving for elimination, the best way to set this up is to keep the variables on one side of the equation and keep the constant on the other side. So I'm going to do that for both equations. So equation 1, I'm going to move this variable, write it as y plus 1/2 x is equal to 2. In the second equation, I'm going to write this as y minus 3x is equal to negative 5. And we can notice here that y is common between the two equations. So if I wanted to eliminate y and solve for x, you can just subtract the equations. However, this time I'm going to do things a little differently. This time I'm going to eliminate x, and I'm just trying to show you guys that you can approach this multiple ways and still get the same answer. So I'm going to eliminate x this time and solve for y. It's going to be a little bit more difficult, right? Now in order for me to eliminate x and solve for y, what I have to do here is I have to make the x's the same coefficient, right? They're just the same magnitude of the coefficients. So say I wanted to make them both 3x, okay? So in order to do that, I need to multiply something by a half to get to 3x. So the way I'm going to do this is I'm going to take equation 1, I'm going to multiply 6 to 1/2 x to get to 3x. Now I can't just multiply 6 to one of the terms. I have to do this for all the terms. So I'm going to take equation 1 and multiply everything by 6. So you get 6y plus 6 times 1/2 x is equal to 2 times 6. If you multiply all your terms on the left side and the right side by the same value, you've kept it the same. So if I simplify this, you get 6y plus 3x is equal to 12, right? And this equation and this equation mean exactly the same thing. Sorry about that. And this is the new equation that I'm going to be working with. So this is 6 times equation 1. Now this is equation 2. We have y minus 3x is equal to negative 5. I want to eliminate x. So if there's positive 3x on equation 1 and negative 3x on equation 2, what I can do here is add the two equations. So I'm taking 6 times equation 1 and I'm adding it with equation 2, right? So if I do that, what's going to happen here is you get 3x plus negative 3x cancels out. And what you want to do is you can add them just on basis on their columns, right? So you can just add them separately based on the columns. You're just grouping like terms. So 3x, positive 3x, negative 3x cancel out. You get 0. 6y plus y is 7y. And 12 plus negative 5 is 7. So you get 7y is equal to 7. You divide this by 7, y is equal to 1. Now that you know that y is equal to 1, if you want to solve for x, substitute y is equal to 1, and let's plug this into equation. Let's plug it into equation 1, right? And you basically get y is equal to negative 1/2. Whoops. So instead of 1, I'm going to write 1 is equal to negative 1/2 x plus 2. I'm going to move the 2 to the other side. So 1 minus 2 is equal to negative 1/2 x. You get negative 1 is equal to negative 1/2 x. If you want to solve for x, I'm going to multiply negative 2 to both sides. So it cancels out. X is equal to 2, right? So therefore the point here is 2 and 1. So that's how you can solve for the point of intersection. So you can actually either eliminate y, solve for x, or eliminate x, solve for y. It doesn't matter which method you take. You guys can test this out by eliminating the other variable this time. But it doesn't matter which step you take, you basically will arrive in the same destination. So that's a really important concept to understand. Okay, so let's take a look at solving a more complex system by using the elimination method, right? So in this case, we have 3a over 5 minus b over 2 is equal to 9, and 3a over 4 plus b over 3 is equal to 17. Let's call this equation 1 and equation 2. I want to solve for a and b. Okay, so what is a and b? The way I'm going to do this is, let's get rid of the fractions. And the way you can get rid of the fractions is you multiply by the lowest common multiple. So let's take a look at equation 1. In this case, you have 5, 2, and 1 on your denominator. So you want to find out the lowest common multiple between these three numbers. And the lowest common multiple that all of these guys multiply into is 10. So I'm going to multiply equation 1 by 10. So if I multiply equation 1 by 10, I'm multiplying 10 to the left side of the equation and the right side of the equation, right? So I do 10 times 3a, which is 30a over 5, minus 10 times b, which is 10b over 2, which is equal to 9 times 10, which is 90, right? So 30 divided by 5 is 6a, right? 10 divided by 2 is 5, minus 5b is equal to 90. So this equation and this equation mean exactly the same thing. The only difference here is that it's a lot easier to look at, right? So if you guys don't like fractions, best case scenario is, you change it to whole numbers. Now let's take a look at equation 2. So in equation 2 here, the lowest common multiple looks like 12, right? If you look at 4, 3, and 1, I'm going to multiply equation 2 by 12, and you get 12 times 3a over 4 plus 12 times b over 3, and this is equal to 12 times 17. So in this case, you get 12 times 3a over 4, so you can write this as 12 over 4 times 3a, because you can change up the order, right? You can do 12 divided by 4 first, that's 3 times 3a, plus 12 over 3 times b, is equal to 12 times 17. If I punch this out of my calculator, you get 204. So if I simplify this a little bit further, you get 3 times 3a plus 4 times b, which is equal to 204. That's 9a plus 4b is equal to 204. These are what my new equations look like. I'm just going to rewrite them for you guys. So this is 10 times equation 1. We had 6a minus 5b is equal to 90. And 12 times equation 2, it looks like 9a plus 4b is equal to 204. So now that we have that figured out, what we want to do is perform the elimination step. Now we need to eliminate one variable and isolate another, and you can choose either or. What I'm going to do is I'm going to eliminate b and isolate for a. Okay, so let's eliminate b, isolate for a. And if you want to eliminate b, what you want to do is you want to make the coefficient the same for the first equation and the second equation. And we have negative 5b here and positive 4b. Let's find the lowest common multiple for those guys. Let's call it 20, right? I'm going to make both of them 20 so I can cancel them out much more effectively. So what I'm going to do now is I'm going to take equation 1, I'm going to multiply it again by 4 this time. Right, so I'm going to do 4 times equation 1 now, from here. And when I do that, I'm going to multiply all of my terms by 4, right? So you're doing 4 times 6a minus 5b is equal to 90 times 4. Okay. Now if I look at equation 2, you want to make the b here with the coefficient of 20. What I'm going to do here is I'm going to multiply all of this by 5. Okay, so this time I'm multiplying everything by 5. So you get 5 times 9a plus 4b is equal to 204 times 5. Okay, so let's simplify this out, right? So this is our new equation 1. So our new equation 1, let's change colors just to show that we've done a transformation to this. Right, so our new equation 1 here is going to be 4 times 6a, which is 24a, minus 4 times negative 5b, which is 20b, is equal to 90 times 4, which is 360. Okay, now equation 2 here, well, get rid of that arrow, but if you multiply the 5 outwards, 5 times 9 is 45a, 5 times 4b is plus 20b, and 204 times 5, if you punch this in your calculator, it is 1020. Now what you can do here is, if you want to cancel out the b's, I'm just going to add equation 1 with equation 2. If I add the two together, and the steps are, it is a little grueling in a sense, there's a lot of steps involved. But if I add these two equations together, you can see that negative 20 plus 20 is 0. Right, so this becomes 0. Right, and you can add up the columns, guys, but remember to never mix and match your left side with your right side, right, because the equal sign acts as a barrier. Okay, so this is basically, you can add it up this way if you really want to. And then we do 24a plus 45a, which is 69a, and this is equal to 1020 plus 360. And the reason I've added is because you have a negative and a positive. So if you have opposite signs, you add the two equations. If you have the same signs, you would tend to subtract the two equations. Okay, and this is 1380. Right, so now you have 69a is equal to 1380. If you want to solve for a, I'm going to divide by 69 on both sides, and a here is 20. So now we've solved for a, what you want to do is you want to solve for b now. I'm going to substitute into one of the two equations that I looked at. I'll substitute into equation 1. Right, so instead of a, I'm going to plug in 20 minus 5b is equal to 90. 120 minus 5b is equal to 90. And move the 120 to the other side. Negative 5b is equal to negative 30. If I divide by negative 5, b is equal to 6. So now that we've calculated that, we've substituted in, we actually have two answers. So a is equal to 20 and b is equal to 6. And that is our final answer. Okay, so that's how we've solved the two equations. And if you plug these values into both equations, they'll give you the same values and it'll satisfy the equation. Okay, so that's the idea, right? So this is basically how you can solve a linear system using the elimination method. It was just a little bit more challenging because of the fact that we had fractions, so we had to constantly make or multiply by the lowest common multiple.